we get from
Okay, so
0.6428?
you got 0.6428, clear
Yeah.
0.6428 and did the inverse sine and you get 40 degrees.
Sine.
And if you do the sine of 40, it's 6428. And if you put in 140 sine, it's also 64.28. And why is that? Because the sine curve, right?
Yes.
So you know, it goes like this, right? This is at 90 degrees, this is this is 180, this is 270, this is 360. And right here at 40 degrees, we get 0.6428, and that's the same as this, which is at 140. Okay? So when you put in 0.6428 in your calculator and you say inverse sine, what does your calculator give you?
First point.
The smallest angle. So whenever you use sine, you have to realize that the angle that you're getting is going to be the smallest angle. So when you got 40, what Mark did is he looked at the picture and he said, there's no way that could be 40, it's gotta be more. When you use law of cosines, you don't have to deal with that problem. Because in this first area, acute and obtuse, you're dealing with positives and negatives. So if you have 0.7660 negative, and you say inverse cosine, you're going to get the 140, because it's a negative. If you put in 0.7660 and positive, and you say inverse cosine, well then you're going to get the 40 degrees. So cosine is helpful because it's positive when it's acute, and obtuse, negative when it's obtuse. So the goal here is for you to realize that whenever you use law signs, whenever you use signs, your calculator will always spit out the smallest value. And when you're using sine, it could be a problem. Okay? And we talk about this in statics, so whoever's taken statics. Did you take statics already? So next semester, in Porter, you're probably taking statics next semester, you're gonna, same exact example. Okay, so now let's look at our third problem. So in your packet, it has the problem, and the next page, it shows the problem, shows the picture. So let's look at the picture first. Let's figure out what's going on here. It's called trigonometric leveling. So everybody look up here, please. See how this instrument goes? It's angled up, right? So it's not a level, because we know a level is always horizontal, right? So this is the ground surface. Does everybody see that this is the ground surface, this squiggly line? Here's our tripod where the instrument is sitting. Okay? So what do you think HI stands for? Height of instrument. Height of instrument. Over here, on the upslope, there's a rod. And what I'm reading is called the rod reading, and that's what little r is. Here we have, everybody look up here, here's a right triangle, right? So here's the change in elevation of the ground here and the ground here, which is really the vertical distance here. And here's our horizontal distance. What is S, what do you think S stands for? The slope distance. And now let's look at these two angles. If I look up, and these are all vertical angles, right? Because it's on the vertical plane. If I look up and I come down to a point, that's called my zenith. Up and down, we'll use these words again. Zenith, that's why they're using Z. If you measure horizontal and go up, that's when they're using the variable alpha.
From the horizontal.
Yeah, sure. So when you look up first with your telescope and then you come down to a point, that's called the zenith angle. If you're looking horizontal and then you go up, so this is an angle from the vertical and this is an angle from the horizontal. That's just referred to in this diagram as alpha. But they're both vertical angles.
Thank you.
So they're both vertical angles. Zenith has a specific name. This does not have a special name. Okay, so we're really looking at trig, aren't you? You know, there's a lot of right triangles here. So H represents the horizontal distance, S stands for the slope distance, Z is the zenith, alpha is the vertical. I didn't give you, what's on the bottom? Let me see the sheet that you have. Good. The bottom part, I don't want you to see the bottom part. So what are you trying to do now? Let's go back to that page before. I'm giving you what Z is, it's 65 degrees, I'm giving you what the height of the instrument is, I'm giving you what the rod reading is, and I'm giving you what H is, and I want you to find alpha, S, V, and the change in elevation.